And to conclude our lightning views and the research view from an academic perspective, I invite Professor Nelson Fonseca from the Institute of...
You're the dark to light, you're never satisfied, you only know the things that will fail to be. The pessimistic one.
So Christian asked an email, sent an email yesterday asking some controversial issues. So I decided to make a report on our lab. I hope it's not much controversial. So this will be a report from the Computer Network Laboratory at the Institute of Computing at UNICAMP. E aqui em cima? Esse aqui, aqui vai para frente, né? Sorry, this in Portuguese is Laboratório de Redes e Computadores, and we have like 4 professors, Professor Edmundo Madeira, myself, Professor Luiz Bittencourt, and Professor Leandro Vilas. We have also collaborating professors that are from other institutes, other universities that join us. It's open for you if you want to collaborate with our lab. We have approximately 3 postdoc, 23 PhD students, and 13 Master of Science students. And we have been working along these years in different topics. And current topics are wireless, optical, networks, cloud and fog computing, network virtualization, IoT, intelligent transportation system, network management, machine learning applied to network problems, and also video service. Along this year, we have formed over 150 PhDs and master students, published over 100 papers, 20 awards in thesis contests, several best paper awards, and different projects founded by Brazilian agency and industries. Our alumni are spread around the world, both at academia and also in industries. And so now I start our presentation about network slicing. In May, we finished this project that's also with the European Union called Football. This Football was a project for integration of wireless and optical networking. And we have different participation from Brazil and also from Europe. So I'll bring what has been done in this Football project about network slicing. Actually, this Football project, it was oriented to define a control frame for the integration of wireless and optical network. And so we had like network slice of resource, and slice orchestration, and to focus also on software-defined radio and NFV with the integration of not only wireless and optical, but also what we call packet opticals, packet networks that are IP networks in the electronic world. So in this, we defined this architecture. We have here the virtualization layer, and we concentrate more on the control and the control plane in the orchestration layer. So there were three orchestrators that were defined. One was the orchestration for the network convergence. The other was for an orchestration for containers. And the third one for a cloud orchestrator. So the first one integrated the wireless and optical and packet networks. What was the code? It was, I forgot the name, it's AMBO. The second one was COPA, which was a container orchestrator. And the third one, this cloud orchestrator. So we have here this substrate, and it was connected to this fiber testbed, and we had a different, what we call islands. No? We didn't have an island here in UNICAMP. What we had was a testbed for IoT, which was connected to one of these islands, and can be used to reserve resources in this IoT platform. So the football control plane, as you can see here, the control plane takes this virtualization and orchestration layer. And we also work with the NFV. There were some use cases that we saw, the set mobilities of VNFs and this type of things in the use case. So this basically was the a picture of what was a testbed. The project was oriented to extend this fiber testbed with this integration. The key issue was the integration of wireless and optical network, define this control plane in the light of this new technology that's NFV. So we have different use cases. The first one was to see the impact of broadband wireless in the optical backhaul. The second one was design of SDN infrastructure for wireless and optical integration. And the third one was the interplay between wireless and optical network for IoT, which is this one here. Which was a test bed at UNICAMP. So using COPA, we were connected to the Rio Grande do Sul island. And anyone from the internet could configure these sensors. We have sensors in different buildings. And these sensors, we have sensors in the data centers, sensors in our building, our Institute of Computing, and they were connected by fiber using radio over fiber technology. So anyone in the internet could configure these sensors and also could configure networks of sensors. So taking some sensors in one building, taking sensors in another building, and making it a network using the fiber with radio over fiber technology. And so this was our building block to the network slicing in this testbed. So this was our contribution to the football. And now we're going to talk a little bit about the work in progress that we have students working in the labs. And so the first work is the application of the use of reinforcement learning to network slicing. So the idea of having the management using this reinforcement learning is not only for the admission control, but also to dynamically reallocate resource given the fluctuation of the network, of the demand, of the traffic. So basically there is these two boxes that we are working, the admission control of slices and the reallocation of resource given the dynamic demands. And it's used that emulator. The second work that is in progress is network slicing in 802.11ah networks, with a network for low power and massive access of IoT. And in this technology, in this Wi-Fi technology, we have that periodically you have like a train, a batch of slices, and these slices given there in the standard, you have a function that you can set for mapping devices into these slots. No, sorry, I saw train of slices. No, train of slots. So you have a mapping of devices to these slots, and these slots are sent periodically. And between these slots, you have a random access, and you can, of course, you can have mapping of more than one device to a slot. No, it's not TDM, of course. It's also random access to this access. So what was defined here was defined, have different devices in IoT with different requirements and traffic characteristics. And what was defined the broker. This broker using SDN, and this broker accepts solicitations, requests based on slicing templates. It gets statistics of how the network is loaded, the demand, and it was defined in two approaches. One that is static, which you map in a static way these devices to these slots. And another one that's called dynamic, which you, based on the network activity, based on the network load, you can redefine, you can readjust the resources, the resource allocation to different slices, reallocating these slots in this batch of slots, which is called the raw. So, so this is what I just explained to you. Based on you can make the reallocation, the dynamics, reallocation of the mapping of slices to the slots in this raw. And this work was based on simulation using NS3. And these are some results that you can, showing that you reallocate the resources dynamically to different slices. So the conclusion is that preliminary work showed improvement when you have a dynamic approach. The final work, a thesis that's also in progress, is a proposal based on SDN to provide slicing in LTE networks. And this is also based on simulation. So we have here three students work, like one based on emulation and the other two based on simulations. So these are the work we have been conducting there.
Thank you, Professor Nelson. And now